Trigonometric functions of real numbers. In this video lesson, we will assume that you have a basic understanding of the 6 trigonometric functions and degree measure. Also, we will assume that you have some exposure to radian measure. So we start with the definition of the 6 trigonometric functions on the unit circle. So if t is any real number, and the point xy is a terminal point on the unit circle determined by t, so that is to say, if we start here at the point 1, 0 on the unit circle, and we trace counterclockwise on that circle to some point p, xy, and the distance that we travel on the circle here is what we refer to as t, which is a radian measure of an angle, then we have the following definitions for these 6 trigonometric functions. And I won't say them here, but you can read them for yourself. In the first example, we wish to find the 6 trigonometric functions of each given real number t. So in part A, we have t equals pi over 3. So we need to remember the 6 trigonometric functions. So we know that sine of t is equal to y, cosine of t is equal to x, tangent of t is equal to y over x, and then the other 3 functions, secant, cosecant, and cotangent, are reciprocals of the ones that you see here. So in this particular problem, we have the sine of pi over 3, and that is going to be equal to the y value of the point that corresponds to t equals pi over 3. Now I have that point here. These are special values according to the value of t here. And I am assuming that you have had some experience with degree measure and radian measure and special values. So the y coordinate of this point is radical 3 over 2. And if for some reason you don't know where those values come from, I would recommend maybe pausing this video and looking at one of my other videos from my trigonometry playlist where you can find this information. So now cosine of pi over 3, that is simply going to be the x value of the point, and the x value there is 1/2. And then tangent of pi over 3, the definition is y divided by x. So the y value is radical 3 over 2, the x value is 1/2, and so that is going to be radical 3 over 2 divided by 1/2, which is radical 3 over 2 times 2 over 1, which simplifies to radical 3. Now the rest of the trig functions, so we'll do cotangent of t next. That is just the reciprocal of tangent. So if tangent is y over x, then cotangent is x over y. So that's going to be 1/2 divided by radical 3 over 2. And when you do the simplification on this, you end up with 1 over radical 3. Secant of t is equal to 1 over x. And this is going to be equal to 1 over 1/2, which is equal to 2. And cosecant of t is 1 over y, and that is 1 over radical 3 over 2, which simplifies to 2 over radical 3. And just for clarity here, I really should be putting the value pi over 3 in for t here, but these are the 6 trigonometric functions of the value t equals pi over 3. Now for t equals pi over 2, we basically go through the same thing. So let's notice that, first of all, the point on the unit circle corresponding to t equals pi over 2 is the point 0, 1. So let's go ahead and set up our trigonometric ratios. And now we just need to go in and find the point here. And of course, in that point, x is 0 and y equals 1. And so we can fill these out. The sine of pi over 2 will be 1. Cosine of pi over 2 is 0. Now, tangent of pi over 2 is 1 divided by 0, which is undefined. So some values of some trig functions are undefined depending on which value you are at, right? So for pi over 2, tangent is undefined. Now, cotangent of pi over 2 is x divided by y, which is 0 divided by 1, which is 0. Secant of pi over 2 is 1 divided by x, that's 1 divided by 0, and that is also undefined. And cosecant of pi over 2 is 1 over y, which is 1 over 1, which is equal to 1. So the real question when finding values of trigonometric functions, especially when you're looking at special angles, is do you know what those values are? So here I have the unit circle with the special angles. So the special angles between here and here are going to be 0, pi over 6, pi over 4, pi over 3, and pi over 2. Let's keep in mind that these correspond to angles, special angles that is. And so, of course, this is 0 degrees down here. This will be 30 degrees here, 45 degrees here, 60 degrees, and then up here we have 90 degrees. So the reason pi over 6, pi over 4, and pi over 3 are special angles is because they correspond to special angles in degree measure. So you don't have to necessarily memorize this table. In fact, really all you need to do is try to memorize the points here, and this is not as hard as it looks. These 2 points are very easy to memorize, of course, 1, 0, and 0, 1. At pi over 4, the x and y values are equal, so these are fairly simple. And then at pi over 6 and pi over 3, notice that the x values and the y values just get switched. So if you can memorize one of them, you kind of automatically know the other one. Now, the good thing is, if you're talking about a special angle in one of the other 4 quadrants here, it's going to be these same values, but the x or y coordinate might be negative depending on which quadrant you're in. And so here is a more complete unit circle with all of these special angles listed on it. And it actually has the special angles in both radians and also degree measure. So this is kind of a useful diagram here. And then as I was saying, if you look at the values of the points in the other quadrants, you'll notice that it's the same values that you had over here. But for example, in quadrant 2, the x coordinate is negative, but the y coordinate is still positive. And in quadrant 3, both coordinates are negative, right, etc. So this is always a useful tool if you have it at your disposal, and it can really make the work for finding trigonometric values of special angles very, very simple. And so for our next example here, let's find some of the trigonometric values in the other quadrants. So we'll start with cosine of 2 pi over 3. Now, memorizing all 4 quadrants of the unit circle is kind of a big task, so I don't actually recommend doing that. But if you just know the first quadrant, you can often find what you need by just knowing these particular values. So let's go ahead and take, for example, the cosine of 2 pi over 3. What we know is that 2 pi over 3 is in the second quadrant, and we know that the reference angle here is pi over 3. And we know this because the angle from here to here is pi, and so this angle would just be pi minus 2 pi over 3, which is pi over 3. Now, what that means is that the cosine of 2 pi over 3 is going to be the same as the cosine of pi over 3, except for the fact that the cosine function is negative in the second quadrant. And that's because cosine is defined to be x, and x is negative in the second quadrant. So if I use a first quadrant value to find the cosine of 2 pi over 3, I have to remember that we have to put a negative in front of that. So now the cosine of pi over 3, we just look at our unit circle here at pi over 3. We know the cosine is the x value, which is 1/2. And so this is simply going to be negative 1/2. For the next one, tangent of negative pi over 3. Negative pi over 3 is since it's a negative angle, is going to go clockwise pi over 3 units. So the reference angle for this angle is actually pi over 3. And so if I want to find the tangent of negative pi over 3, we know it's going to be equal to the tangent of pi over 3. And now the only question is tangent negative or positive in the fourth quadrant? And we should remember that tangent is positive in the first and third quadrant, and it's negative in the second and fourth quadrant. So yes, this is going to be a negative value, and this is going to end up being negative tangent of pi over 3. Again, we look at pi over 3, and we take the y value divided by the x value. And so that is radical 3 over 2 divided by 1/2, and when you simplify this, you get negative radical 3. And finally, for the third one, the sine of 19 pi over 4, we have to ask ourselves, what is the angle or the value 19 pi over 4? Well, we should know that every time you go around the unit circle, that is an angle of 2 pi, and 2 pi is the same as 8 pi over 4. So one revolution is 8 pi over 4. Another revolution would be another 8 pi over 4, so that would be 16 pi over 4. And then so 19 pi over 4 is just going to be plus 3 pi over 4 to the 16 pi over 4, right? If we add 3 pi over 4 to 16 pi over 4, we get 19 pi over 4. So 8 pi over 4 is one revolution, 16 pi over 4 is another revolution, and then 19 pi over 4 is just 3 pi over 4 additional. Now 3 pi over 4 has a reference angle of pi over 4. So the sine of 19 pi over 4 is going to be equal to the sine of pi over 4. The only question is it positive or is it negative? And what we should know about sine is that it is positive in the first and second quadrants, and it is negative in the third and fourth quadrants. So the fact that 19 pi over 4 is in the second quadrant means that sine is going to be positive there. So the sine of pi over 4 is equal to radical 2 over 2, and so that is the value of the sine of 19 pi over 4. Next, we have the reciprocal identities. Sine of t and cosecant of t are reciprocals since the sine of t is equal to y and the cosecant of t is 1 over y. Secant of t and cosine of t are reciprocals for the same reason. Cosine of t is x and secant of t is 1 over x. And tangent of t and cotangent of t are also reciprocals. Tangent, of course, is y over x and cotangent is x over y. So we can sometimes use this fact to find values for the secant, cosecant, and cotangent functions. So for example, using a calculator, let's find the following. The sine of 2.2. Now when you're doing this, you have to realize that this angle, 2.2, is radians because there is no degree symbol here. So that means that we have to make sure that our calculator is in radian mode. So once we do that, we basically just type it in and we get our answer. And so to do the sine of 2.2, we're just going to type in sine of 2.2. On most calculators, it'll look just like that. And then we hit enter, and we're going to round these to 4 decimal places. And that is approximately 0.8085. Next, we have the cosine of 1.1. Again, we're just going to type this into the calculator just as we see it. And just want to reemphasize, you've got to make sure our calculator is in radian mode. And you can see that what we get here is approximately 0.45359, which is 36. Now for the next one, it's a little bit more complicated. We have the cotangent of 28. Now, we don't have a cotangent button on most calculators. So the way we're going to type this in is going to be 1 divided by the tangent of 28. And on the calculator, it's automatically going to put parentheses around these. But let's go ahead and type that in. And you can see that we get a value of approximately negative 3.5533. And finally, we have the cosecant of 0.98. And this is 1 divided by the sine of 0.98. And again, we just type this into our calculator, and we get an approximate value of 1.2041. Now keep in mind that we're using a calculator here because these angles that you see here, these values, are not special values. So we don't have them memorized like we do some of the others. All 6 trigonometric functions are either even or odd. So sine, cosecant, tangent, and cotangent are all odd functions. The cosine and the secant are even functions. So what this means basically is, remember the odd functions, which are sine, cosecant, tangent, and cotangent. When you take a function value of a negative number, you get the opposite of the function value of the positive number. So that's what it means to be odd. And then, of course, to be even, when you take a function value of a negative number, it is the same as the function value of a positive number. So, for example, if I want to find the sine of negative pi over 6, if I don't feel like dealing with negative pi over 6, because negative angles are not as easy to think about, what I can do is just remember that sine is an odd function. Therefore, this is equal to negative sine of positive pi over 6. And then we just have to know, well, what is the sine of pi over 6? Well, it is 1/2, right? But then we have to make sure that we make it negative after that. And the cosine of negative pi over 4, same thing. But this time, cosine is an even function. So cosine of a negative angle is the same as cosine of the positive angle. So this is equal to the cosine of positive pi over 4. And this is radical 2 over 2. Next, we have some fundamental identities. So we already talked about the reciprocal identities. You can look at those here. The other fundamental identities are the Pythagorean identities. And I'll just briefly talk about why each one of these is true. So if you consider being on the unit circle at some point P here, which has coordinates x and y, I can draw a representative triangle where this side of the triangle is x, this side of the triangle is y, and the hypotenuse is 1 because it's the unit circle. We know that x squared plus y squared must be equal to 1. But we also know that x is the cosine of t. So x squared is cosine of t, quantity squared. And y is the sine of t. And so y squared is the sine of t, quantity squared. And then, of course, we can abbreviate this with cosine squared t plus sine squared t is equal to 1. And this is the first Pythagorean identity. Now, the other two identities, these ones here, come from just simply taking this formula, so taking x squared plus y squared equals 1, and then either dividing both sides by x squared or dividing both sides by y squared. So for example, if we divide both sides by x squared over x squared is 1, y squared over y squared is the same as y over x quantity squared, and 1 over x squared is 1 over x quantity squared. And you can see that y over x is tangent, so that's going to become tangent squared. 1 over x is secant, so that's secant squared. And then you can see that turns into the identity 1 plus tangent squared is equal to secant squared, which is the second one here. And then the third one you can find by simply dividing by y squared instead of x squared. So these Pythagorean identities and reciprocal identities are considered to be fundamental identities, and you should definitely have all of these memorized. So as an example, we can find all trigonometric functions from the value of one trigonometric function by using those identities. So in this case, if we know that cosine of t is 3/5, and if we know that t is in quadrant 4, we want to find the other trigonometric functions at that value of t. So for example, since we know that sine squared t plus cosine squared of t is always equal to 1, this means that sine squared of t is equal to 1 minus cosine squared of t. And if we take the square root of both sides, we get sine of t is equal to plus or minus the square root of 1 minus cosine squared. So now, if I want to find the sine of t for this particular problem, first of all, we have to remember that if we're in quadrant 4, sine is going to be negative. But then it's just the square root of 1 minus the value of cosine quantity squared. And they tell us the value of cosine is 3/5. So this becomes negative square root of 1 minus 9 over 25. And that is negative square root of 16 over 25, which turns into negative 4/5. Now, once I have the value of sine and cosine, I can find the value of all of the other trigonometric functions. So for example, we know that secant of t is 1 divided by cosine of t. So that's going to be 1 divided by 3/5, which turns into 5/3. Cosecant of t is 1 over sine of t. And so that's going to be 1 over negative 4/5, and that is equivalent to negative 5/4. And then to find tangent and cotangent, tangent is simply sine over cosine, because we know that tangent is y over x, and we know that sine is y and cosine is x. So all I have to do is divide sine of t, which is negative 4/5, by cosine of t, which is 3/5. And when you invert and multiply here, you get the value negative 4/3. And then finally, cotangent of t, you can do this two different ways. You could say that it's cosine of t over sine of t, or you could simply take the reciprocal of tangent. So it works either way, but in either case, you should get negative 3/4. And finally, we can use the identities to write one trig function in terms of another. So in this example, we want to write tangent of t in terms of cosine of t. So what we do know about tangent is tangent of t is equal to sine of t divided by cosine of t. And so all we really need to do now is write sine of t in terms of cosine of t. And in the previous example, we talked about how sine of t is equal to plus or minus the square root of 1 minus cosine squared of t. So I can replace sine of t here with this, and that's going to give us plus or minus the square root of 1 minus cosine squared of t divided by cosine of t. Now, if we also happen to know that we're in quadrant 3, we need to know that tangent in quadrant 3 is positive. So I can then choose the positive sign here, which means I could basically just get rid of the plus or minus. And so tangent of t is equal to this expression if we know that t is in quadrant 3. And that concludes this video lesson.